Hey everybody! How are you? Alright, let's jump into solving equations that contain radicals. I didn't show you in the previous section some of the calculator stuff because it isn't, for the most part, you are going to have to do it by hand, but I want to go back just a sec and show you that some of these you can put in the calculator. Ones like this you can put in the calculator, just for an example. Now, you can do this when you only contain numbers, so that is the catch. I didn't necessarily want that one, so let me try to delete this. When you have only numbers and no variables, see how if you have a variable in there, you can't put it in the calculator. But one like this, you could. Negative 216 raised to the negative 1/3. And of course, weird things always happen, but so you get that. Now the only challenge is this doesn't convert you back into a fraction, but it does give you the answer, and then you would just have to figure out that that's the same thing as negative 1/6. Okay, or putting it to the handheld calculator would go ahead and give you the fraction by doing math enter. So you can do that on some of these, but of course if it's a variable thrown in there, then you can't really do it with the calculator. But kind of more focusing now on the calculator stuff with the solving of these equations, we'll go ahead and use the calculator a little bit more. So to solve radical equations, so equations with radicals, the first thing you're going to do is isolate the radical on one side of the equation, so get it by itself. Okay. One helpful tip is after you do this is if the other side is negative, if the opposite side of your radical is negative with an even root, then your answer is no solution. Then you have no solution. Okay, that's just kind of a tip, but we'll see also what happens when we graph it. So then after that, we raise each side of the equation to the power of the index to eliminate the radical sign, because we know that the opposite of a radical is the exponent, to cancel it out. Then we will solve the remaining equation, and then we have to also check for extraneous solutions. Remember, that means we take our answers and plug them back into the original and make sure that both of them actually work. Okay, so we'll go ahead and do it by hand and also do it in the calculator. So we're going to isolate the radicals, so that means I have to move this 5 over. That's step number 1. That would become 7. Okay. And then from here, x is not by itself, so as you know, to undo a radical, we want to do a squared. So we square that side and we square that side to cancel it out. That will leave us with x, and then that will give us 49. Okay, so x is 49, and then just to be sure, plug in 49 back into the original. Square root of 49 is 7. 7 plus 5 is 12. Yeah, we're all good there. All right, and then just to see also what this looks like in the calculator. So the square root of x plus 5 equals 12. Just type in the whole equation. And if you don't see anything, like on yours, you probably don't see anything, that means you have to zoom out. So when you zoom out, you will see, let's change this to a, can I change this to a color? I thought I could. Well, there's a way, but I forgot. Oh, there it is. It was a little bit slow. You can zoom in and you can see, now it doesn't show you the answer up here, but you have to look at the graph and see that it's intersecting at 49. Okay, so there you go. That's the first one. Let's go ahead and do the second one. So we isolate the radical, so we're going to have to move this 3 over, meaning we're going to have to subtract 3. What's left is negative fourth root of m equal to negative 3. And if this is a negative and this is a negative, I know I can divide by negative 1. And divide this side by negative 1, and the negative 1 goes away, so I'm left with fourth root of m equals 3. Then I raise this to the power that is the index, which in this case is 4, so I raise both sides to the fourth power. Giving me m is equal to 3 to the fourth power, which is 81. So m is 81. Okay? Alright, some big answers there to start with. And yes, fourth root of 81, 3 minus, is 3. 3 minus 3 is 0. Yeah. So we're all good with that one as far as checking our answers. Alright, I'll leave you to try this one. Let's go ahead and do number 4 together. Isolate the radical, so we want to minus the 10. Three minus 10 is negative 7. Okay? So, what happens in this case is what I said up here. If the opposite side is negative with an even root, then we have no solution. So this is automatically, if you remember that, you're going to remember that this is no solution. Let's see what happens when we try to graph it. Alright, so this is, now, let me show you this. You cannot put in the original variable, like it has w in this problem, and it will not work in Desmos. It won't give you an answer. So what you need to do, it'll give you this error right here. That means we got to change it back to an x. So it likes variables of x, y, and z. So that's the order of variables that you need to use in this. So let's see here. So let me make sure I got everything right. 6x minus 5 plus 10. Oh, I didn't change the ending to a 3. Alright. Oh yeah, that changed it, definitely. Now I see that I have nothing. Right? So there we go, a no solution. Now let's hypothetically say we kept going. So as a graph, it was no solution. If we kept going and raised both sides, you would square this side and square this side, and you would end up with 6w minus 5, radical goes away, equal to negative 7 squared is 49. You'd add 5. 6w would equal 54, and then w would equal 54 divided by 6. Math, enter, enter, and giving you 9. So you would think initially, if you didn't catch it, or if you don't graph it, that the answer is 9, okay? But that is, as I was saying, that is wrong. What happens if we plug 9 back into the original? So we'd have radical of, and this is where you, another way to check to see if it's extraneous. Plug in the 9. 6 times 9 is 54. 54 minus 5 is 49. Seven plus 10 equals 3, and 17 is not equal to 3. So see how when it works out, plugging that number, if you forget about that negative thing, you could potentially end up with a wrong answer, 9 instead of no solution. But that's why it's really important to check those back in. Or, as you can see, graph it in Desmos. Desmos shows nothing. So that's a good indication that your answer is no solution. So see how we got to be careful on some of these. Okay, either graph it in Desmos to double check your answer, or take your final answer and plug it back into the original to see if you get a true statement. Okay, So that's just some things to look out for. All right, let's see if we got anything else here that looks a little bit crazy. Oh yeah, so now they throw in some where we don't have the radical and you got to put it in the radical form. I think we can handle it. Let's start by doing one together just to make sure you're on the right track. So what this means is this is a radical and we're going to try to get it back. Or try to change it back. You really don't have to, but for the purposes of practice, let's do it. If you recognize that this is going to be a square root, you can just move the 9 and then square both sides, and then that'll cancel out. But for visual, let's go ahead and say, all right, that's 1/2. That converts to a regular square root of c minus 12. And I want to isolate the radical, so I want to divide by -9. Negative 36 divided by -9 is what? 4? Those will go away, so I'm left with radical of c minus 12. So this is where I check to see if this is negative. The negative went away, so we're good to keep going. Square both sides, so square this side, and I end up with 16 equal to c minus 12. I want to add the 12 to the other side, so adding 12 to 16 will give me 28. And just to be sure, let's check it in the calculator. So that would be negative 36 equals -9. And change my c to an x. And then raise to the 1/2. Okay, and there's our answer. Can't tell, zoom in until you can tell what number it's going through. It's going through 28. Yeah. Okay. Let's see, did we have any of those on the back? Oh yeah, the whole back is practice on those. Woo! Okay. Go ahead and practice any of them that you want. And so press pause and then play when you are ready to see. There are some that have 2 answers. We should do that. Okay, let's look at one that has 2 answers, number 13. Okay, so it is isolated. Okay, the radical is already isolated, so if we're doing this by hand, we would say, all right, I got to square this side and square this side. So squaring this will leave me with 8x equals x squared. Okay, oh, lovely. That's just lovely. Not. I think we're going to have to hold off on these. Because that's going to give us a quadratic, and we haven't done quadratics yet. Okay, I'm glad we went over this. So let's eliminate those ones. We want to eliminate these ones that are quadratics. So let's just eliminate 13 to the end for now. So do not worry about 13 to the end, okay? Maybe another day we'll come back to those. Just do up to number 12, and then you can see the answers after you pause the video and then press play. So, all right, good luck. All right, so we have 3, which came out to be -6. We have number 6, which comes out to be -9. Number 7 is no solution. Number 8 is 6. Number 9 is 17. Number 10 is 10. Here's 11 and 12 worked out. So with the radical on both sides, you can't really isolate you can only isolate one radical at a time, which is fine. So the way on number 11, I isolated this radical by dividing both sides by 4. That simplified this side to 3 radical q. So this radical is by itself. So I went ahead and squared, and that's what my 2 means. I squared this side and this side. Squaring this side eliminates the radical. Squaring this side will square both items. So I squared the 3, which became a 9, and squaring radical cube got rid of the radical. So that's nice. I mean, it still eliminates the radical on both sides. And then you move the q's to the other side, divide by 6, end up with 5 halves, and either graph and Desmos or plug it back in to make sure you get an equal equation. And then on number 12, raise both sides to the third power. They are already, this one's already isolated. Raise them to the third power. This one out here, I went ahead and changed this radical to an exponent, so that'd be n to the 1/3. Negative 2 raised to the third power is still a negative number. When you raise it to an odd power, it's still negative. And then 1/3 times 3 is 1, so it's really n to the 1. And then resulted in 14 divided by 2, giving us the 7. So, that was pretty quick, nice and quick compared to the previous ones as far as solving equations. All right. So next, coming up, we will do a little bit of graphing. And hey, we can use the calculator for that. Woohoo!